I do hope that we are soon ready to start with our conference. Peter braucht noch ein bisschen. Okay. Guten Morgen, meine Damen und Herren. Muy buenos días, estimados señoras y señores. Good morning, ladies and gentlemen. I'm happy to open the sessions of today. You remember yesterday was a very fruitful day, a very good opening of the soil classification conference, and we would like to continue today the same way. And I would like to introduce the first keynote already. This is Curtis Monger, and you know him. He is a very exposed soil scientist, very successful in soil classification, soil genesis, and he will give us a talk on soil taxonomy and the philosophy of Julius Stuart Mill. So I will go down, but the floor is yours, Curtis.
Okay, thank you, Carl. And I want to be sure the microphone is working. I think it is. This one's working okay. Good morning, everyone. I'm very glad to be here, and I wanted to just say a few words about when I was a professor till 2015. I worked with many of you, and I got to know many of you during that period. And then I took a job with the U.S. Department of Agriculture as the National Leader of Soil Survey Standards from 2015 to last year, 2021. And the reason I bring that up is because that is when I became interested in the philosophy of John Stuart Mill and how John Stuart Mill's thinking is in taxonomy. It's fundamental for soil taxonomy, and that's what I want to talk about. And I retired from the USDA August 28th of last year, and now I'm back at New Mexico State as Professor Emeritus. Great job. I help teach some, but I have graduate students write grant proposals and attend conferences like this. So, okay, so the talk is about John Stuart Mill and soil taxonomy. And who was John Stuart Mill? Well, he was an English philosopher, a political economist, member of parliament, civil servant. But if you read his writings, he was a very early advocate of women's rights during that time period. And most of his philosophy that's in taxonomy came from this book, A System of Logic. And it's a very thick book where he basically articulates many things. Classification is one, but he builds on the work of Francis Bacon, the experimental method, multiple working hypotheses to drive at scientific conclusions. So I wanted to start out with this question, or statement rather. And when I was in the position with the USDA, my department oversaw the technical documents, which included soil taxonomy. And we would get lots of questions from people in the field mapping soils about, does this meet, for example, the criteria for a cambic horizon? Said, well, we're not really sure, but we'll check on it. And the way that we would check on it is we would typically start with the keys. And many times the answer was in the keys, the most recent keys. You just had to read a little further or reread some of the definitions or go to somewhere else in the keys to find the answer to the question. But many times, I don't know. We don't know the answer to that question. So this is the procedure typically that we would go through to try to find the answer, is we would go through the second edition, this purple or mauve color soil taxonomy that's published in 1999. And there's a lot more material in there, a lot of explanation about all the different taxa. If we didn't find it there, we'd go back to this green book, the 1975. If it wasn't there, we'd go to the seventh approximation that was published in 1960. And if it wasn't there, we'd go to the Guy Smith interviews and see if we could find the answer in the Guy Smith interview. So let me walk through these, starting with the Soil Taxonomy second edition, 1999. So this is still the authoritative reference for soil taxonomy as used, except for a few taxa that now exist in the keys that didn't exist back in 1999. And it's available PDF online. So if you ever have any questions about, for example, the subgroups, where do they occur? On what landforms do they occur? Are there any special characteristics that need to go into an explanation? All of that is laid out in the second edition. And taxonomy was built by Guy Smith. He was the leader, but many people, and it was an international system where pedologists around the world contributed to this. It was a matter of getting that understanding of international pedologic intellect and trying to put it into taxonomy. And there were international committees that were set up, and they studied, for example, when I was a graduate student, there was the ICOMID, the International Committee on Aerosols, and a group of people from all over the arid regions of the world worked their way across and discussed and argued, debated. And all of those international committee reports, the findings are in this 1999 edition. But no mention of John Stuart Mill. So I don't know if it was space limitations. It was already a thick book, and the group that was putting it together, this is after Guy Smith, said there just isn't room for philosophy on classification here. But anyway, it doesn't make it to the 1999 version. But if you go back to the 1975, there's a lot of philosophy and a lot of rationale in the 75, and there's some direct quotations. I'm going to dissect those with you, and more discussion of the classification. And Marlon Klein, he was a professor at Cornell University, and he was very much instrumental working with Guy Smith to put this material together. I'll magnify these in just a minute just to show you, some of the quotations. John Stuart Mill said, and John Stuart Mill pointed out. That's the type of philosophy that made it into taxonomy that's in the 75. And then these are really good papers for understanding the development of taxonomy philosophically. Klein 49 and Klein 1963. Okay, so we didn't find the answer in the 1975, so we go on to the seventh approximation. And again, there's one direct quote, John Stuart Mill, reference Marlon Klein. But this is a really interesting book for teaching. And there's all this science in there. There's all these thin sections in there, and rationale in the seventh approximation that again got cut out in later issues, and even more discussion of philosophy of classification than in the 75. And I'm just going to pull out a one page and enlarge it and see if hopefully that's large enough that you can make it out. But they have statements like classifications are contrivances, and that they're not truths in themselves that are discoverable. So, for example, the earth isn't a sphere. Isn't flat, it's a sphere, and it's a sphere not in the center of the universe, but it is going around a local star in a galaxy among many galaxies. Classification doesn't have those discoverable truths. Like when you burn something, it releases phlogiston, as what was thought at one time. No, it's all based on the purpose of the class. What's the classification made for? And for example, when I taught soil classification, the students, first day of class, they'd come in and you could say, okay, all the students that have a hat on over here, all the students that don't have a hat over here. And you've just made a classification based on whether or not people have hats on. So class is all about what's the purpose that you're trying to get to. And also that as we learn more, classification is going to evolve, and it should evolve. It should not be stagnant, but it should be a very dynamic system. So let's say we didn't find it there, so we go to the Guy Smith interviews, and I think the core idea is that the best taxonomy is the one that permits the greatest number of most important statements. And this might get back to the Babel concept that Erica talked about yesterday. I'm not sure, it'd be interesting to have that conversation with us. And the other important idea that Guy Smith writes about in the interviews is both John Stuart Mill and Bridgman had a very large effect on me. Now, Bridgman, he had written a book called The Logic of Modern Physics, and this was in 1934. But it was about operational definitions, and we've encountered that many times during our field trip, our field excursion. And that is, okay, on what method do you base percent clay? On what method do you base electrical conductivity? On what method do you base? And it's very important to specify the methodology of how the ideas are being quantified. And so that was Bridgman. And so Guy Smith, the other thing was, it's got to be quantitative. And a lot of these definitions are really tough because they're so darn quantitative. But everything has to be defined numerically, even color, 10 wire, 4-2. But he goes on to say that Bridgman and John Stuart Mill, that he had read many books, but he bought those two books for his own library. He said they had an enormous impact on me in the development of soil taxonomy. So let me go to the first quotation. Here it is magnified, and I just want to dissect it and some of the important ideas. But a good taxonomy is one that can be remembrance that you can carry with you in your head when you go to the field. And so the Greek and Latin root words. A lot of people that are not familiar with taxonomy and they see this name, right away they're turned off. It's like, what is this? And you say, give me 3 minutes, just 3 minutes to let you know that these are words that are in the language, generally speaking, that many people are already familiar with. And it's a matter of taking these symbols and starting from the right, working to the left, like Hebrew or Arabic, and you basically just build that name from right to left. And once you show them that, and once you show them the root words, I think they get it. They get it right away. But the point is, it's something easily remembered. That was the first point from that paragraph. Then the other principle was, okay, classification is all about, you've got a bunch of objects and you put them into groups, okay? This is saying put them into groups in which there can be derived the greatest number of propositions. What does that mean? Well, this is my interpretation. For example, we have soil moisture regimes that come in high in taxonomy, and there are many propositions that can be inferred from those with respect to, number one, use and management, number two, genesis and profile properties. But take the aquatic moisture regime, for example. To know that a soil has an aquatic moisture regime, you can infer right away that from an agricultural standpoint, yes, there are some crops that might be grown, but many crops cannot be grown. Same's true with forestry, same's true with engineering, aquatic moisture regime, no septic tanks, you're going to have a lot of problems. So that would go up high as something that many propositions can be derived from. Next, genesis, aquatic moisture regime. Well, right away we can infer things about redoxymorphic, gley, organic carbon. On the other end, the aeritic moisture regime, in terms of genesis, well, secondary carbonates, salts, items that properties you wouldn't find in more humid regions. Okay, so put that high in the taxonomy. Moving down, that he makes the statement that most often what is obvious is not the best property. It's not the most important property, that unobvious. For example, if we go back to Curtis Marbett's classification, and like right now, if you look at soils in New Mexico, this publication needs to be updated, but they're based on color. The color is the highest category. So if you look at brown soils, okay, what do brown soils tell you? What do gray soils tell you? Well, there are some inferences you can make from those. But if you compare brown soil, and if that brown soil is an Ustauf, right away, an alpha sol, we have O horizons that come to mind. We have E horizons. We have BTs. Of course, a lot of that's plowed, and those are gone. And the argillic is now at the surface. But a lot of information, and this one being in a semi-arid moisture regime. Okay. Then working your way down to the end of this paragraph, what is meant by importance? And that's where it differs. And the example Erica showed yesterday about the Russian, the WRB, the taxonomy with respect to cryosols or gelisols, and just the differences, but importance. And again, important for what? Important, what does that mean? Consequential. Consequential for what? What do you want it to be? Does it need to have practical ends? Is that what it is? Or are you like a botanist and you just want to know what's out there in nature? But what is the end? Okay, very important in terms of the structure. Then if we move to the other quotation, I wanted to magnify for you. And this is all about one thing, and that's genesis. And what he's talking about here is should be possible from which many causes. What is the cause? What is the mechanism? Cause and effect from which other properties are derived. And it comes down that unfortunately, seldom can you base a classification system on causes, on not the properties, but the processes, the mechanisms. And I know Spinoza, talked about that too, about the begetting and the begotten, when Darwin, I'll go off on a tangent just a bit, but natural selection, and the diversification of different, just the biodiversity, that there's a lot of processes that result in results. Even geology, the mountains that we've seen, those are the results of processes. But we don't classify the processes, the mechanism. We classify the result, what's left. And that's what he's getting at there. And this was mentioned earlier about the World Congress in Madison in 1960. And back in those days, they transcribed everything that was spoken, pretty much. And it's really quite the record. But here's an exchange between Charles Darwin and Cuvier, and they're talking this subject about Genesis versus properties. And Cuvier brings up the point that soil genesis deals with the explanations of how a soil or the entity came to be formed, and that we don't classify these properties. And Charles Kellogg agrees with him, and I think emphasizes it, that yes, we do not classify the causation, but we do classify the properties. And that last statement there, we use Genesis, but it is one step removed from the classification itself. And this is so easy to observe. And I think I would dare say every excursion I've ever been on dealing with soil classification, that Genesis is such a major part of those discussions. And I think all of our sites that we saw on the field excursion, but this, are there lithologic discontinuities in that profile? That was quite the discussion, quite the great discussion, quite the necessary discussion. And that's what people like to talk about. But again, the point is that we're not classifying the mechanisms, the processes. We're classifying the properties that result from those. That's the point that I'm trying to get across here. And to bring it a little bit more in terms of emphasis, here's a great paper that goes back to 1963, Threads of Genesis in the Seventh Approximation. And the author, Arvard Klein, goes through and basically is saying that pick any one of, at that time, the orders. They're based on diagnostic horizons, and those diagnostic horizons are all about Genesis. And even the Intisols, there is no Genesis. That's right. So the Intisols were, to preserve the azonal soil concept, there's no petagenesis. And so therefore it's based on Genesis or lack thereof. One other example, Roy Simonson. In this paper, is going back looking at the evolution of soil survey and soil mapping and classification in the United States. And he talks about going back to the early days of Whitney. And he's saying, this is, I think, quite the interesting statement, but back in those days, that people would look at the bottom of the cut, not the top of the cut. So if there's a road cut, and there's a lot of road construction back in those days, so they were looking at the sea horizon. And the sea horizon, is it loess? Is it alluvium? Is it glacial till? Is it limestone residuum? That's what they were after, and add a little texture to that. So this is Whitney's map that came up, and it's pretty much a parent material map. So the yellow in the southeast, that's coastal plain. You can see all the, what we would now call the fluvents along the rivers. The green in the upper Midwest, that's the continental glaciation boundary. That orange, those are the big pluvial glacial lakes. The light blue is the limestone residuum. And that was soil until Curtis Marbeth discovered Dokuchaev and Dokuchaev students. And so Curtis Marbeth, the Russian thought had been already translated into German. So Curtis Marbeth taught himself German so that he could translate Glinka's work, because Glinka had it, that really summarized the Russian thought. It's already in German. Curtis Marbeth teaches himself German and then translates that into English. And at that point, this map changes to that. So every one of these we still have with us a little bit today in some form. So in the southeast, that pink, those were what we call the ultrasols. Back in those days, these were podzolic. They weren't podzels. The podzels are the blue up high. Those are what we now call the spotosols or the podzol. But the pink, those were podzolic in the sense that you had the O, you had the A, you had the E, you had material being carried down vertically in the profile. And these were the podzolic red and yellow soils. Above that, the yellow, those were the podzolic gray and brown soils. Now we call them the alpha soils. And then you get into the Midwest, the phaeozyms, those tall grass prairie soils, thick moloch epipetons, but no calcium carbonate, not much, until you keep going west and you cross into the Chernozyms and keep going west into the Casazyms. Maybe mispronouncing that. And of course now in taxonomy, they subdivide that into like the mollisols, the humid ones, the udols, and then the ustols. But anyway, that's it. That's a Genesis map that came about from Curtis Marbeth discovering the ideas of the Russians by way of the Germans. So I would say if Arvard Klein were here, I would say this paper isn't strong enough. Instead of threads, support cables. That everything in taxonomy pretty much is related to Genesis. So kind of a summary of that is, Genesis, you can understand the accessory properties is arid, okay? You make inferences about carbonates and so forth. But the big thing in terms of mapping is the accuracy of the map. And so if you go out and drill holes in the landscape and try to connect the dots, yeah, you can make a soil map. In some cases, it might be a pretty good soil map. But if you really understand the genesis of that landscape, you understand where those young sediments are, you understand where those old geomorphic surfaces are, where you've got petagenesis occurring for a long time, you get strong argillic horizons or strong petrocalcic horizons. If you really understand that genesis, then you can make some accurate maps. I remember my brother-in-law, he's a civil engineer. One time he said, we use soil maps all the time. He said, how do you guys know what's down there? And, I didn't give him a good explanation, but that's it. A really good map is somebody who really understands the genesis of that landscape. And just an example, you can take any block diagram. I put it in here. I like this block diagram. It's showing this ancient mid-Pleistocene geomorphic surface in the desert north of here. And got a petrocalcic horizon that's formed, but that is so old that it's gone through many glacial fluvial periods. It's gone through at least 8 glacial, interglacial cycles. And during the wetter glacial cycles, that's when the lakes around here fill up with water and you still see the shorelines. But basically, that's when that petrocalcic horizon becomes karst topography. And now you get, sinkholes in the petrocalcic horizon. And then you shift back to an arid period. And now the depth of wetting shifts up and you form carbonate over those sinkhole material. But just an example of how understanding the landscape and then understanding that, okay, we've got these soil individuals or polypedons, and we try to get a representative lab sampling of those so that we can really understand. And then the last point is his second book, and this is more all about human nature. And in here he talks about two things that really are pertinent. And a group of individuals, whether it's scientists or name the group, but in our case, we got a group of scientists, pedologists, soil taxonomists, and you can just see it in this conference that individuals pursuing their own interests, whether it's artisols or what, really contributes. It really enriches. And the point that he makes is it's a really good thing for individuals to pursue their own interests, their own good, as long as it doesn't interfere or deprive others. And you can see it, for example, in our case, in the U.S., the soil moisture regime's high. You got folks in the East, and it's all Utic, and they think it's wasted space. But the people in the West say, no, it explains the forest boundary and the grassland boundary, and it explains as you go through the mollisols into the back into the alpha soils and the high. And but that would be one example. And in the National Cooperative Soil Survey, it's all about getting a whole bunch of people to try to agree nationally, and we don't have the international component that we did have at one time, which is very unfortunate, to try to come to some consensus that, yeah, definitely subaqueous soils, bueno, go for it, is good, but don't put the aquasalids in it, for example. And then, but the other point that he makes is any type of documentation really does need to be challenged. And it's a great thing to have fundamental challenges because it gives you an opportunity to defend the system as it exists, but also it prevents dogma. So absolutely, bring it up, question it, debate it, and then go with the idea. If it's a good idea, maybe a great idea to make a big change. It could be a great idea. So that's John Stuart Mill. That's ways that he contributed to soil taxonomy, and that I thank you. And there's my email, by the way, if anyone needs it, to carry on conversations or future collaborations or so forth. So thank you.
Thank you a lot, Curtis. You brought us to the roots back and the philosophy behind it. And often when we discuss things, we only see the actual purposes of our doing, but not the whole frame. So we have a lot of time. You did not use all your time. So we have a lot of time for discussion. And I invite all of you to put questions to Curtis Monger. Who is willing? Okay, come ahead.
Professor Monger, thank you very much for your conference. I didn't know who was John Stuart Mill. I wrote a little book about the different soil classification school, Russian, Soviet Russian, school, European school, and North American school. I will include in the future this idea from John Stuart Mill. Thank you very much.
Good. Great. Okay, thank you.
You have to, you want to answer it?
Well, that was a comment. I think.
It was a comment, it's
Yeah.
clear.
Oh,
yeah.
that, my comment to his comment, fantastic. Thank you.
Thank you.
I think it's a great idea. Yes. Yeah.
Okay, go ahead, please.
Curtis, I also thank you a lot for this talk, which brings us to the basic principles from which we are very often isolated or at least distant in our everyday practical research. I have a question which I have since many years to soil taxonomy, and maybe now this is the moment to direct it to you as the representative of this great classification. I understood now from your talk this approach of application of general propositions to grouping of objects into some groups or units. What I am always be a little bit worried is the number of these propositions. What do I mean? Let's go to the top level of soil taxonomy. Mollisols, alphisols, spodosols, defined according to certain substantial characteristics related to genesis. Aridisols, climate and soil moisture regime, absolutely different general proposition. Antisols, no substantial characteristics, no climate, but the grade of evolution, primitive soils, evolutionary proposition. We are somehow accustomed to basic classification principle related to biological, botanic classification of Linnaeus. One principle for one taxonomic level. For example, type of flower and fruit. There is no situation in botanic classification when one plants are classified according to their type of flower and the other plants according to their, for example, growing in the humid tropical or arid climate. So I don't think that this is a question, maybe it's more a comment, but do you think that this general proposition in the classification should be uniform or at least limited for certain taxonomic level, or such diversity as suggested by soil taxonomy is possible and have future? I'm not sure that my question is really clear, but I tried to express it as clear as it's possible for me.
Okay. And
Thank you, Charlie. I think this is a comment which
well.
can be commented.
okay, right, yeah. And your comment was very good too. Thank you. So classes. We're talking about putting objects into classes. So let's back all the way up to particle size, sand, silt, and clay. I mean, there's a continuum in sizes there, but we make boundaries. We put them into classes. That is one class. And then those in turn get scaled up and grouped into more and more and more classes. So for example, we say a mollifipeton. We're talking about more Then organic carbon. Organic carbon is a very important part of mollifipetalon, but a mollifipetalon or horizon is a synthesis of many properties. And then we come up with this idea in our minds or contrivance about entities on the landscape. And we all know soils differ across the landscape. But a three-dimensional entity on the landscape. So it's easy to imagine a lake, is very uniform, in its material makeup, and its mass, its matter. And it has three dimensions, 2 dimensions on the surface and a third dimension. Soils do too. Soils have these 3 dimensions. And that's the other idea, and it's brought up a couple of times, but the soil body. We've got conceptually soil bodies on the landscape composed of many different properties, a synthesis of properties. And another thing that Roy Simonson said in that paper that I showed is, he said the most important thing we learned from the first 50 years of mapping soils in the United States is that a soil series is based up of many properties uniquely combined. So, for example, I could tell you about, I grew up on the Fullerton Series, and no one would know what that is, but if someone did know what it is, they would understand that it's many, many properties. It was, the O and the A and the E and a huge thick, we're talking 30-meter thick argillic horizon with such a little bitty alluvial horizon. And that we talked about that a lot, about mass balance. There's no way that alluvial horizon could, in some of these cases, account for all of that clay. But it's a synthesis of properties that would come up with these conceptual boundaries for bodies on the landscape. So what's out there in nature? But again, going back to the early days when they were making soil maps, the Congress and other people who are developing policy said, oh, those are pretty maps, but what good are they? So that's where you bring in the utilitarian purpose is, who cares about the scientists care about them, and, like the botanists care about biodiversity and so forth, but of what good are they to society? So we not only have the scientific aspect of what's out there in nature, but utilitarian, what's it good for humanity? I think, and that's where a lot of the definitions, were broken, were derived. So, yeah, Sergey, that's my comment to your comment. Is that even close to what you were getting at? Yeah.
Maybe I am allowed to make a comment on the comment.
Okay, go ahead.
Yes. So, if I understand right, Curtis, the utilitarian principle make the classification and maps of soils useful for the broadest community possible is the main purpose. And for this purpose, you could sacrifice uniformity of basic principles, of definition of groups, just to make it more useful. It is more important that this soil has acidic soil moisture regime than all other characteristics. So we define this group according to its regime. And for healthy soils, it's most important, again, for practical use of broadest community, that it has thick clay alluvial horizon, and we defined it according to this very different principle from arid soils. Is this right?
That is right. Yep. Yep.
Now I got it. Thank you.
Yeah. And just to add to that real quick, so the acidic moisture regime, the boundary was the sown, what could be sown versus the unsown. Yeah, you might sow it, but it's not going to grow without irrigation. And so that was very much a utilitarian boundary. And it coincides, like we said, with a lot of, properties in the profile. But that was an example of an agricultural bias boundary.
This is something very different from Linnell's and classifications of the 18th century.
Yeah. Okay. Good. I'm sorry. Yeah.
May I put a question in between, a short one? You mentioned soils are three-dimensional. Now, for me, it's very important that all soils are four-dimensional, not only three-dimensional. And my question would be, can this be taken from soil classification or soil taxonomy, that they really take into account that soils are four-dimensional?
The Paley Great Group's attempts to do that. The idea, okay, there's a soil in the landscape that has a long memory. What is evidence of that long memory? And that would be an abrupt clay content that doesn't decrease with it. It's not stratigraphic, it's pedogenic, and it would have taken, for this particular soil, many millennia to develop such a strong profile. That's one example where the fourth dimension could be derived. Yeah.
Ben, you?
Yeah, Curtis, this last week at a soil pit, when Erica was the pit manager, she asked for the genetic horizons to be described, identified and described. But another conclusion that I made was that we were never really sure about Genesis. Talking about Genesis opened up such a lot of questions, especially as newcomers to a particular soil pit. So it seems a contradiction then to persist with the idea of genetic horizons as opposed to simply morphological horizons. Sure, Genesis is important when you're working in a landscape and you need to understand the geomorphology and how the landscape is derived, but simply purely for a soil profile, I guess in Australia we've tended to go to the more purely morphological approach as opposed to a genetic approach. So just maybe a comment on that, please.
Yeah. So for a specific profile, typically it does take a detailed study with multiple hypotheses about how this soil, from a genesis standpoint, could have resulted, and just trying to eliminate those, okay? And so it's a much longer, more detailed study. But in general principles, to have a clay enrichment with argillans is fairly solid evidence that there is vertical migration of platy clay particles. And then you couple that with thin section, we got the argillans, where the clays are lying tangential, parallel to the surface. Oxasols, being able to trace something laterally, the same parent material from say a temperate zone into a tropical zone, and just watching how the weatherable minerals disappear, and all that's left are the most insoluble minerals. And again, that's Genesis, that's morphology B lowercase o, but it's a general principle. It's just extremely highly weathered, and the mineralogy tells us that. So, yeah.
We have possibilities for more questions. Cesare, go up.
Return to philosophies, to the roots, and we can ask, for example, why soil taxonomy has not been fully accepted years ago as the only international system. Yes, probably I know political various reasons, but in my opinion, breaking of the direct and visible relation to soil origin could be one of such reasons. Yes, because I think, in my opinion, as I can feel it, discussing with colleagues in various countries, it is large expectation that soil classification systems will clearly reflect the relationship to soil origin. And for example, in WRB, it is probably much better recognizable for people. And maybe this is why WRB for people also, thanks to names used for soil groups, is for at least for some people in some countries more acceptable. Because if we look to national classification, still this very close relation of classification to various concepts of soil origin or soil diversification, distribution is very, very strong. But absolutely, I agree that there are various users of classification. Yes, what is important? Just concentration of only on origin, or also on soil properties, services, because various users may also say taxonomy is not only for classification of objects, which we know, but classification should give us, especially maps, should give us additional knowledge, useful knowledge for farmers, various users. And there are really important question how to construct classifications in relation to which, how to say, paradigm. And what we can, for example, observe in WRB, that sometimes when we create diagnostic criteria for particular reference group, sometimes after some time, people report, based only on this diagnostic criteria, report their soils which have completely different origin and were developed in completely different environmental conditions as the soils originally, how to say, understood as the typical in this unit for whom the criteria was created. And if it is combined with traditional name of this soil unit, as we have, for example, castanozems, yes, it is clearly related to specific concept of soil origin and zonation. And if organically we have soils from another territories developed in another way, but they meet the criteria, what to do? This is important, how to say, trouble in this relation between, how to say, concept of classification. In this way, morphological classification, which breaks the direct relation to origin, works better. But if expectation is that it should be still kept. Thank you for, it is not a question, but I just wanted to say that the topics you showed us are really of primary importance for all people who discuss, who develop classification systems worldwide. Yes, so thank you for this review and remarks. Thank you.
Thank you. Yes. Yeah. Just, okay. We're okay. Two comments. Equifinality has been a word used to describe that you've got different processes that lead to the same result. And you can imagine that, again, to use tropical soils and oxisol, there might be some soils that on the fourth dimension get there by way of alpha sols, or by way of ultrasols, or by way of just intersols going, intersols having oxic sediments. And so it's a very quick path to there. So equifinality, definitely. But again, the genesis, the fact that you can trace their different origins, to get to the final product enhances understanding. And so when I was at New Mexico State the first time, my office neighbor was a hydrologist and an engineer. He didn't want to know anything about taxonomy. He wanted to know percent sand, silt, and clay, and just properties. That way he could plug them into his models. But that'd be an example of like, you could, for the continent of Africa, have a property map showing the percent sand in the upper 10 centimeters for the entire continent. And that's a lot of, but for people who even know a little bit of taxonomy, if you can say, here are the oxasols, that is a much deeper understanding of the soils of Africa, you know. And then the other thing is, taxonomy. It's good, in my opinion, that taxonomy isn't the classification system. I think that's a blessing, really. It's supplemental. It can help, but it's like buying local. You know, when you're local, it's more useful. I think, in my opinion, healthier, greater diversity to use the local classifications and other classifications. So.
Thanks. We have still time because not the next, but the third paper is missing. Therefore, we can use a little bit of time. Cesare, you allow me?
May I have additional question or comment?
Okay.
Because it is also a very important question what you asked, time as the fourth dimension. And in soil classification, we should recognize two aspects of this question. First, normal development of soil from young soils to well-developed soils, or factors which rejuvenate soils. And I think this aspect is quite well recognized in soil classification, also in soil taxonomy. Beautiful distinction between anti-soils, incepti soils, and other soils. But there is also another aspect, polygenesis of soils, yes, or variant soils. It is also a time-dependent process, and there is, I think, largest problem for classifications, how to include the paleosoils, yes, or polygenetic soils, how to apply the criteria which we developed for the first, order of soils, yes, to merge in classification all the aspects of the fourth dimensions you asked, yes. So for me, there are, as I told, two aspects. I think in soil taxonomy, it is also partly, both aspects are partly, a second aspect is partly developed also.
Yeah, good comment. One question over here.
Okay, one more question here. I would like to allow myself also to put it last question then.
Professor Kalsztar, can I?
Yeah. Yes.
Yeah? Okay. Okay, also comment. But at first, I think the presentation of Curtis is very great because stimulate us for the public conversation and exchange of ideas more than questions. I think what Czarek said before, that four-dimension time, it's also not so easy to put this aspect because some soils, for example, anti-soils in soil taxonomy, or some weakly developed soils in other classifications, not necessarily are dependent only on time. For example, in Arctic conditions, in high mountains, very weakly developed soils are we can say, climax soils. They cannot develop more because of conditions. So not only time, but sometimes conditions complicate this situation. And my personal feeling is that this problem that we still look at the soil, at the profile, by the visible features like soil horizons and so on, so genetic features, and we, in the same time, look for parameters which could be as much universal as possible and measurable, is the biggest problem of all the soil taxonomies, not only about soil taxonomy of USA, but also WRB and many national classifications. Because we classifying different soils, we use different criteria, as Sergei said. And probably until we do it, and we will do it for sure, because it's very visible things, soil morphology is the first thing which we see. And this puts our mind into the direction in which we are thinking. But later we are looking for some parameters, chemical, physical, and so on, which not always are visible in the soil profile. Okay, thank you. It's just a comment.
Yeah. Yeah, I totally agree. That was a good comment. And it's interesting to think about different velocities of time that, yeah, a frozen soil or a soil saturated with water versus a, say, loess, you know, with many weatherable minerals, and how rapidly through on that fourth dimension petagenesis does modify the soil. Yeah, so good.
Felicitaciones por su presentación, doctor Curtis. Nuestro grupo de trabajo está enfocado a la conservación de los suelos, en particular lo que nosotros lo denominamos la zona crítica. ¿Por qué? Porque consideramos desde el punto de vista generalmente de los hidroedafólogos que el suelo es la zona crítica.
Thank you very much for your presentation. Our group is working in the degradation of soils, particularly in the critic zone, because it is important by the point of view of the hydrological studies.
Y es el centro de la zona crítica. Y en ese sentido es muy importante poder comunicarnos dentro de nuestros objetivos de poder pues, contemplar de una manera muy exacta, como lo dice aquí, el hecho de que se enfrenten varios retos del funcionamiento de los suelos en relación con esta zona crítica que comprende los límites de la vegetación en la parte externa y el contacto con el manto freático en la parte interna.
And it is important to understand and to research this critical zone, because it is the contact between the part of the vegetation and also the part of the hydrological resources.
Por lo tanto, pues tenemos que ser muy claros para comunicarnos con otras ciencias como es la física y las matemáticas. Entonces, mi pregunta es, ¿qué tantos avances existen en relación con objetivos puntuales que evidentemente son el tener certidumbre del comportamiento de la fase líquida, la fase gaseosa y la fase sólida del suelo?
And it is also important to integrate other disciplines like the physics, the maths, the modulation. So the question is, what are the advances of these integrating studies to the soil to understand the phase, the gas phase, the liquid phase, and the solid phase of the soil?
Mm-hmm.
That's my,
Yeah.
that's my,
Yeah, that's the question, please.
esa es mi pregunta.
Yeah.
What are the advances of integrating other disciplines to understand all these phases, the liquid phases, the gas phases, the solid phases?
And I think within a soil science department, where you have the soil physicists, the soil chemists, the soil microbiologists and biologists, that the pedologists are the ones that integrate. I mean, the pedologists understand about available water holding capacity and the difference between volumetric water and pressure or tension to pull water off. They understand cation exchange capacity. They understand the importance of microbiological. So I think we pedologists, are at the center that synthesize a lot of disciplines.
Okay.
Well, okay, thank you.
Okay. Yeah. Okay.
Well, I would like to allow myself to put the last question. So we all agree that soils are formed through the influence of soil forming factors. The time was discussed, it is a parent material, it is the climate, it is the relief, are the biota. Increasing problems I have with man, because man behaved originally like a biota, and meanwhile man behaves like geology and changes soils in this way. Now, if we describe soils and classify soils, we are normally not able to fully show the influence of the soil forming factors, at least not directly. But the soil forming factors, they cause processes. And I think the processes are the most important things happening in the soils. However, still you see some things. We look to the clay cutants, and they are directly a result of a process. But many other things we observe in soils do not show us directly processes. And therefore, for soil description, and we need to use the properties. You mentioned this several times. We need the properties. However, for me, the properties are not sufficient. If you only use properties for describing and classifying soils, you cannot cover the whole what soils are. So therefore, we need some connections between properties and the processes. And is there a principle behind in taxonomy or so where you can say, yes, we use the processes, but in relation, the properties, but in relation to the processes active in the soils?
I totally agree that if you could synthesize the result versus the causation, that there is that connection there, and that connection can be very complex. Just to say, okay, we classify the results and we use the causation to explain it. Maybe we can do better. Maybe that's an opportunity for young pedologists, young scientists to take that on as a challenge to make that connection better. Yeah.
Okay.
Okay. Okay.